Hey, hey, hey! You jumped this. What?
Sorry, I can't understand sign language.
Every act of communication is a miracle of translation. I am Brent Joshua De Castro, a researcher from Negros Occidental High School, presenting my study entitled as
I Go Between, app-based Filipino sign language translator in the text and speech using neural network. Hearing enhances speech, language development, and understanding. However, hearing loss affects over 20% of the worldwide population. FSL is a sign language that originated from the Philippines. However, researchers have discovered that the indigenous signals of FSL are in danger of being lost because of the rising impact of the American Sign Language. Currently, there are a few solutions that has been done in order to solve the problem on communication. One uses an app that converts sign language images into text. There are also a few inventions that uses gloves to detect sign language. However, all of this works only as a one-way communication and does not solve the problem on how disabled people will be able to understand others. The main objective of the study is to develop an app-based device translating Filipino Sign Language into text and speech using neural network. Specifically, this study aims to answer the following questions. The study will utilize a descriptive research designed to answer the objectives. In conduction proper, first will be the collection of the materials, then the construction of the device. For the input system, flex sensors on the fingers, accelerometer on the wrist, and DIY metallic strips at the tip of the finger will input the movement or the hand gesture motion from the hand gloves. It will then be processed by the Arduino Nano, and the data process will be transferred to the Bluetooth module. The data will then be transmitted at the phone's Bluetooth. Once it has been received, visual basic interference will be outputted, and this will then be processed by the phone's application, and then speech output will follow. If the other person will want to talk to the user, then speech recognize will be used. Once the microphone is allowed or turned on at the phone's application, speech recognition process will then follow. After this, the speech will be processed, and visual basic interference or letter words display will be outputted. A real-time sign language detection system will be developed for Filipino Sign Language. Deep learning and neural network will be used in order to recognize gesture motions. The device will utilize speech recognition, and once the speech has been read by the system, the translation process will then proceed. To explain how the model will be trained, the flex sensors will generate voltage once the fingers were bended. This will send the voltage data from the different fingers for the model. The accelerator will send data on what degrees were generated also, and the DIY metallic strip will determine if the fingers touch against each other. All of this will be combined and the model will be developed. After the training, the model is expected to have automatic prediction on detecting letters or words. The robotic gloves will be connected to the application that will be made by the researcher. The gloves will be connected to the app via Bluetooth. This is where the text will be displayed. It contains other more features such as the language translator. The main languages that the researcher aimed to include are English and Filipino, with its different dialects such as Bisaya and Hiligaynon. The researcher will use survey questionnaire as the research instrument to test the acceptability of the device. To test the validity of the research instrument, the researcher will use a criteria developed by Carter Vaygood and Douglas B. Skates by 5 teachers in Annalicious. The accuracy of the translator will be tested by determining if the program translated the words into Filipino true text and speech. The data of this parameter will be collected with the use of research checklist. To determine the Filipino Sign Language in the text, it will be tested by translating the first 50 words in 1 minute. The data analysis and interpretation will solely rely on descriptive research tools such as count percentage, mean, and the standard deviation. The main beneficiaries of this study are the deaf, muted patients, deaf interpreters, deaf and muted organizations. With the development of the device, disabled people such as audibly impaired, mute, and deaf patients would be able to have a better communication than ever.
Once again, I'm Brent Joshua De Castro, and this ends my presentation.